Hey YouTube, thanks for visiting. So in this session or in this lecture, we are going to discuss the calculus of variation. Okay, so one by one in the lectures, we read the calculus of variation part. Okay, so calculus of variation is very important topic for any higher mathematics exams, as well as this is also helpful for any engineering students also, because in some engineering exams, calculus of variation syllabus is also included in the section of engineering mathematics. Okay, so let's start to read the calculus of variation. And before starting, I am requesting you to all those who are watching me for the first time, those who are new in my channel, so please like the sessions or like the lecture if you helpful, or if the lectures is helpful, then please give a like to this lecture, and those who are new, please subscribe the channel. Okay, so let's start the calculus of variation. Okay, so what is the calculus of variation? Okay, now the calculus of variation is concerned with the extrema. Okay, now extrema means what? We have to find a function for which, and function here given a set of functions which we denote by f x y y dash. Okay, this f x y y dash is known as a set of functions, and here one term is also important, which is functional. Okay, now what is mean by functional? So a functional mean is a mapping. Okay, suppose it is a mapping, suppose phi, this is a mapping from what? From a set of functions, from a set of functions to real or real numbers, you can say. Okay, so what do we mean by functional? Functional is a mapping from a set of functions to the real number. Now the calculus of variation is mainly deals with the extrema. Okay, so now here it says that by a functional we mean a quantity whose values are to be determined by one or several functions. That is what a quantity whose values means this is a clearly real number, is to be determined by one or more several variables. So this is known as the functional. Okay, the aim of calculus of variation is to explore methods, different types of methods for finding the maximum or minimum of the functional defined over the class of functions. So this is the motto of calculus of variation, or this is the aim to read the calculus of variation part. Okay, now the simplest variational problem. What is the simplest form of variational problem? So to determine a function yx which makes the integral or the functional, so this integral is known as the functional. Here this I or j, we can denote it by I or j of the function y, which is a function of x also. Okay, this integral is stationary, that is to have prescribed boundary condition. And what are the prescribed boundary conditions? These are the prescribed boundary conditions, is known as the simplest variational problem. Okay, so the what is our aim, what we do to read the calculus, or you can say that why we read the calculus of variation. So calculus of variation is mainly what is to explore the methods for finding the maximum and minimum value of the functional. So this is the functional, so we have to find the methods to maximize or to minimize these functions. Okay, now the main important thing to read the calculus of variation we need is the Euler-Lagrange equation. Okay, now for I equal to integration x0 to x1 f of x y y dash dx, the extremals are given by this. Okay, del f del y minus ddx of del f del y dash, this is equal to 0, and this equation is known as Euler-Lagrange equations. Okay, and using these equations we find the value of, or we find the form of y, okay, which we need to find the extremals. Okay, this type of questions we may see in the exams. Okay, and this equation is also known as what? The Euler's equations only. Some books says it Euler's equations also. Okay, Euler's equations. Okay, Now the other form of Euler's equation is ddx of f minus y dash del f del y dash minus del f del x is equal to 0. So this is the most important thing of calculus of variation. This formula is needed throughout the calculus of variation. Okay, now we did the different types of forms of the Euler-Lagrange equations. Okay, now the other form of Euler-Lagrange equations are if f is independent of x, that is f is equal to f of y and y dash only, then the Euler's equation may be written as f minus y dash del f del y dash equal to constant. These forms are important, but the main form is this one. Okay, if you forget the particular forms, then you can use the main forms to solve the problem, but sometimes we need the this easiest form to solve the problems, and in that case the problems is more easy. Okay, if we use these formulas. Okay, now number 2 is if f is independent of y dash, that is f is a function of x and y only, then the Euler's equation is del f del y is equal to 0. Okay, now number 3 is case 3 is if f is independent of y, that is f is equal to f of x and y dash, then del f del y dash equal to constant. This is the third form. And the fourth form is if f is independent of x and y both, then the Euler-Lagrange equation takes the form del 2y del x to this is equal to 0, and the extremal is this one. Okay, so if we see the problems carefully, and if we find that, or if we see that the form of the f is independent of any one of x or y dash, or it is independent of both x and y dash, and in that case this is particular and special case also. And if we see that if f, or that is the functionals, f is independent of x and y both, then we can directly say that the extremal is of the form y is equal to ax plus b, where a, b are constant terms. Okay, now if we take an example, so the example says that I equal to this one. Now find the extremal. If we see the questions, then how can we solve the question? Now first we see this is the f form, f. Okay, so the f x y y dash. Okay, so this is equal to y square minus y dash. So see, if we see the problem, or that is the f carefully, then we see that this is independent of x. Okay, and if we apply, this is the formula independent of x formula, means this one f minus del f y dash del f del y dash equal to constant. So we can use this formula, and we can use the general formula also. Okay, so the general formula is, now here I can apply the general formula also. Now if we apply the general formula, then the formula is del f del y minus d dx of del f del y dash, this is equal to 0. Now this means what? This means del f del y means 2y minus d dx of del f del y dash means minus 2y dash. Okay, so this is equal to 0, and 2y minus what, d dx of minus 2y dash means this is plus y double dash, this is equal to 0. Okay, now this is 2 only, so this implies y double dash plus y, this is equal to 0. Okay, now this is simply a differential equation of a degree 2 of order 2, you can say. So this means y equal to what, a cos x, I think, plus b sin x. Okay, now if we apply the given conditions, then y0 equal to 0, y0 equal to 0, this implies what, 0, I think, a equal to 0. Okay, and this gives, now this gives what, y equal to b sin x only. Now if we apply what, y pi equal to 0, then we get what, 0 equal to what, b what, and sin pi means also 0, I think. Yeah, or what we can see. Yeah, this is the case. Okay, y pi equal to 0 gives sin pi is equal to 0. Yeah, just a second, I think I write. Okay, yeah, in that case this is the functions and it is given the boundary conditions. Sorry, this is 2 pi, I like to forget. So why 2 pi is equal to 0 means b equal to 0, 2 pi means 1, so b equal to 0. Oh, sorry, this is 1 and 1. Okay, here I write the, so that means this is 1. This is 1, so that means what, we get a is equal to 1 and similarly b is equal to also 1. So the extremal is y equal to simply cos x plus sin x. Okay, so this is the extremal in the of the problem, okay, of the functional, this one. Okay, so this type of problems we solve using this, and there are different types of method. Here we can take another example, which is jy equal to what, integration x0 to x1, this one exponential x into 1 plus y dash square. Now f is equal to, here this is now given exponential x into 1 plus y dash square. Now this is independent of y, and the Euler-Lagrange equation in case of independent of y, so which is, we can write this one, del f del y dash equal to constant equal to c1 if we take. So that means del f del y dash means this one, exponential x into y dash by root under of 1 plus y dash square, this is equal to c1. That is if we simply derivative this term by in okay, with respect to y dash, that means we can write y dash equal to c1 by root under e to the power 2x minus c1 square. Okay, if we square both side and then just find the value of y dash, then we get this one. Okay, this implies, and y dash means dy dx, so y is equal to integration c1 by this one term dx plus c2, this is equal to sec inverse exponential x by c1 plus c2. So the required extremal is this one, y equal to sec inverse exponential x by c1 plus c2. So this is our clear extremal, okay, in this example. Now going to the next one, example jy equal to integration a to b root under of 1 plus y dash square. Okay, now if we see this is the f, and this f is independent of x, y and y both. That means we can write the Euler-Lagrange equation is del f del 2f del y to this is equal to 0, or we can directly write the extremal is given by y is equal to ax plus b. Now if here the conditions is given, then we apply simply the conditions to get the extremal. Okay, this is the problem. Now here we read another two cases, in case the functional is involving higher order derivatives. Okay, so higher order derivatives means, suppose I is equal to integration x0 to x1 f of x, y, y dash and y power n, this is suppose nth order derivative included in the functional, then the Euler equations becomes del f del y minus ddx of del f del y dash plus d2 dx2 into del f del y double dash plus dot dot plus minus 1 to the power n d to the power n dxn del f del y power n, this is equal to 0. That is alternative sign of minus and plus, and one in each term one derivative term मतलब increase होगा यहाँ पे, ठीक है. Now the second case is when the functional have several dependent variables. This is one case, this is another one case. That is integration I is equal to integration f of x1 y1 y2 yn. So these are in several dependent variable. Y is dependent on x, yi's are dependent on x. Okay, and y1 prime, that is this is the derivative terms of nth different dependent variable. Then the Euler-Lagrange equation takes the form del f del y dash del f del y1 minus ddx of del f del y1 dash, this is equal to 0 1, this is 2. So this is the number of equations of Euler-Lagrange equation, in this case increase the number of equations. Okay, if there are n several dependent variable, then the number of equations will be n. Okay, simply n, and in this case the number of terms in the equation increase. Okay, so remind these two things to remember these two cases. Okay, now in this case, this is the last case of Euler-Lagrange equation different cases, when the functional involve more than one independent variable. That is, suppose that the functional f is the function of x, y, z, zx and zy, dx, dy, then the Euler's equation takes the form del f del z, that is here the number of independent variable is more than 1. So in that case, the Euler-Lagrange equation is del f del z minus ddx of del f del zx minus dy of del f del zy, this is equal to 0. Here what the independent variable is y and z, that means these two the independent variable is x and y, and z is dependent on x and y. Okay, so in that case the Euler-Lagrange equation is this one. Okay, so this is an introductory class of Euler-Lagrange equation, calculus of variation. In this session we just discuss the Euler-Lagrange equation, different form of Euler-Lagrange equation, okay, and different cases, okay, different cases including the variables, more than one variables, the higher derivative terms. Okay, so these are the formulas. So in this session or in this lecture I am trying to provide all the formulas or all the important formulas regarding the Euler-Lagrange equations. Okay, and in the previous in the further lectures, in the future lectures, we now covered all the lectures, all these topics and examples of these subcases one by one, and also there are isoperimetric problem and some different problems, and we discuss one by one. Okay, so in this lecture this is the class, and if you like the content then please give a like to this video, share with your friends and subscribe the channel. Okay, thank you friends, see you again in the next video. Thank you.